Today, we're delving into an exciting new discovery that could change how we understand the sun's cycles. Let's get started. Rethinking solar cycles, new physical model strengthens planetary hypothesis. Hi everyone, today we have a fascinating topic that explores the mysterious cycles of the sun. Researchers from Helmholtz-Zentrum Dresden-Rossendorf and the University of Latvia have developed the first comprehensive physical explanation for the sun's various activity cycles. This new model identifies swirling currents on the sun, known as Rossby waves, as intermediaries between the tidal effects of Venus, Earth, Jupiter, and the sun's magnetic activity. This discovery provides strong support for the previously controversial planetary hypothesis. Planets set the rhythm. For years, Dr. Frank Stefani from HZDR's Institute of Fluid Dynamics has been a proponent of the planetary hypothesis. This theory suggests that the gravitational forces of planets, similar to how the moon affects Earth's tides, also impact the sun. Every 11.07 years, the gravitational forces of Venus, Earth, and Jupiter align in a straight line with the sun, creating a tidal effect comparable to a spring tide on Earth. This phenomenon aligns perfectly with the Schwab cycle of solar activity. The sun's magnetic dynamo. The sun's magnetic field is generated by the complex movements of electrically conductive plasma within the sun. Think of it as a gigantic dynamo, explained Stefani. While this solar dynamo produces its own roughly 11-year activity cycle, Stefani and his colleagues believe that the gravitational effects of the planets slightly push and pull the dynamo, enforcing the unusually stable 11.07-year rhythm observed on the sun. A few years ago, Stefani and his team found strong evidence of this process in existing observational data. They were able to correlate various solar cycles with the movements of planets using mathematical methods, although the physical explanation was initially lacking. Rossby waves as intermediaries. We have now identified the underlying physical mechanism. We know the amount of energy needed to synchronize the dynamo, and we understand that this energy can be transferred to the sun through Rossby waves, says Stefani. Rossby waves on the sun are swirling currents similar to large-scale wave motions in Earth's atmosphere that control high and low-pressure systems. Researchers calculated that during spring tides, the tidal forces from Venus, Earth, and Jupiter possess exactly the right properties to activate Rossby waves on the sun. This insight has many significant implications. Explaining all solar cycles with a single model, mathematics plays a crucial role here. The superposition of three shorter Rieger cycles naturally produces the primary 11.07-year Schwab cycle. The model also predicts long-term fluctuations in the sun's activity, as the sun's movement around the solar system's center of mass leads to a 193-year beat period based on the Schwab cycle. This corresponds to another observed cycle known as the Seesta-Vries cycle. The researchers discovered an impressive correlation between this calculated 193-year period and periodic fluctuations in climate data. This correlation provides another strong argument for the planetary hypothesis. The sharp Seesta-Vries peak at 193 years cannot be easily explained without the phase stability of the Schwab cycle, says Stefani. Stay tuned for more discoveries. Thanks for watching. If you enjoyed this deep dive into the mysteries of the sun, don't forget to like, share, and subscribe to our channel for more exciting videos on science and space. See you in the next video. Goodbye.